Okay, this is our second video in Chapter 2. We are describing location and transformations. We're also going to talk about some density curves today. Our AP Statistics Standard, we're still exploring data and summarizing distributions of univariate data, the effect of changing units on the summary measures. That's what we're going to be examining when we're examining our transformations today. Anticipating patterns, we're going to start talking about properties of the normal distribution, and in order to get there, we're going to talk about density curves. So today, how does a constant being added or multiplied to a set of data change the center or spread of the data? So we will find that out in just a minute. First of all, these are the rules for if you're going to add or multiply something to the data. And of course, the addition rule is going to apply to whether or not you're subtracting from the data, and the multiplying rule is going to apply to whether or not you're dividing, because it's just multiplying by some reciprocal fraction. The rules are the same for subtraction and division accordingly. So if we, in a data set, add A to each of the observations, when we look at the summary statistics of center and spread, A is added to the center and A is added to the quartiles, but it doesn't change the spread. So the IQR and the standard deviation do not change. However, if we multiply each observation in our data set by B, the center calculations are multiplied by B, and also the spread measures are multiplied by B. Well, let's look at how that works. Here we have a group of data. These are scores on a statistics quiz. Not you all. You all are much better than this. So here we're going to calculate the mean, the median, the IQR, and the standard deviation of the data. I'm going to go ahead and do that for you. Here's the mean, 70.94. There's the median, 73. IQR is 19. And the standard deviation is 11.43. Now we're going to apply a transformation to the data set. The teacher decides to add 10 points to every grade. And now we're going to calculate the adjusted mean, median, IQR, and standard deviation. Well, given the rules that I just told you, if we add a value to each data point, the mean and the median measures of center will change by 10 points. The IQR and the standard deviation should remain the same. Let's see what happens. The mean went up by 10 points. The median went up by 10 points. The IQR stayed the same. And the standard deviation stayed the same, just as predicted. Now you could go through the trouble of adding 10 to each of these data values and find that out exactly the same way as I just told you. Or you can use your rules. So, another teacher only graded the quizzes out of 25 points. So, we're adjusting the mean, the median, IQR, and standard deviation, given the fact that instead of, say, a 50, we're going to divide that by 4, and we're going to get that it's a fraction. So instead of 100, it's a 25, and so on and so forth. So calculating the adjusted mean, median, IQR, and standard deviation, it should divide each of these by 4, because whenever we're multiplying or dividing, our value for spread and center should change by a quarter. Okay, 17.73, that is a quarter of that. 18.25 would be a quarter of 73. 4.75 is a quarter of 19. And 2.86 is a quarter of 11.43. So just as predicted, that transformation occurred. Another teacher decided to take half of the grade and add 40 points to it. So write the linear transformation equation and calculate the adjusted mean, median, IQR, and standard deviation of the data. So first, they took the grade of x and took half of it, so multiplied it by 0.5 or 1/2, and then added 40 points. So we have two transformations occurring. The mean and the median, being their center values, will be affected by both of those changes. However, the IQR and the standard deviation, not affected by the addition of 40 points, will be affected by the half of the grade, so they should only change by half. Here's the equation of what we did to each data value. Multiplied it by half, and then added 40. And we'll see that the mean and the median were affected in that manner, and the IQR and the standard deviation were only affected by half. Okay, so those are your answers in terms of using the rules of transformations. Now, if you don't have access to the data set, then of course you'll have to use the rules. Okay, let's talk about density curves. What we've done so far in exploring our quantitative data is we've plotted our data, made graphs with it, dot plots, stem plots, histograms, and so forth. Then we looked for an overall pattern, and we described it in terms of shape, center, outlier, spread, and pointed out striking features as well, like gaps. We're going to take, and we also calculated numerical summary statistics, so our one variable statistics. We're going to take that one step further now. We're going to start talking about what we could do to help us explore this quantitative data, and we're going to look at the overall pattern. If it's a large enough number of observations and it's so regular, we can describe it as a smooth curve and not just rectangles such as this histogram here. This histogram is about the ITBS vocabulary score. And if you'll notice, we've got a curve mapping out roughly the shape of this distribution. The smooth curve shows the overall shape of the distribution. And the goal is when we map distributions out from actual data using the smooth curve distributions, the pieces that are outside the curve make up for the areas missing underneath the curve. Okay. The density curve area underneath it always equals 1 or 100%. Okay. Area is exactly 1. It's always above the horizontal axis. And the median divides the area underneath the curve in half. It's called an equal areas point. So half of the area will be to the left of the median and half of the area will be to the right. The mean, however, is what is referred to as the balance point. If it's skewed, then it's going to be pulled towards the tail. If it's symmetric, the mean and the median should be at the exact same point. If it's roughly symmetric, they should be roughly at the same point. But what we mean by the balance point is if we were to have the distribution weigh according to the amount of area that is underneath it, the balance point would be where you could put the mean and it would balance evenly in terms of left to right. And this has to do with things like torque and whatnot. So if you're not a fan of measuring in that capacity, then you can do this test though with like a ruler and putting your pencil underneath the ruler and balancing pennies at equal distances and then seeing where the mean would move, your pencil would move if you move one of the pennies out towards the edge of the ruler. So, fun facts. We should be able to approximate the mean and the median on a density curve. That's one of the goals of what we will be doing. So, let's pretend we have a density curve. It's not exactly a curve. It's a straight line. It's a straight line segment that begins at the origin 0, 0 and has a slope of 1/8. Now remember, what's the total area under this density curve? It's going to be the same area under every density curve. It's 100%. So in order to sketch the density curve, we're going to think of it, okay, Okay, slope of 1/8. Straight line, starts at 0, 0, positive slope. It's going to go up like a ramp. But in order to sketch this, I need to basically come up with the length of this ramp and the endpoint. So we're going to do a little bit of algebra. Remember our area of our triangle, which is what our ramp's going to be? Well, the area of that triangle is going to be 1, the area of my ramp. And it equals 1/2 base times height. And given that my slope is 1/8, my height's going to be 1/8 of the base. So doing a little math, I find out that the length of the base is 4. And then going back into my equation, my height is 1/2. Can I put b back in there? Yes. Okay. And this will be the graph of this situation. So see my ramp? The area underneath this is 1. Now, let's find out some information about this graph. Where's Q1? Now, Q1 is going to be where 25% of the data or area is to the left and 75% is to the right. So in order to perform that calculation, we're going to find out when the area of my ramp is 1/4. And that will tell me the point at which 25% of the area, 1/4, is to the left. So I substitute that into my 1/2 base times height formula that I came up with, and I end up that b is 2. So here, at this point, is the 25% of my area is to the left and 75% is to the right. Relative to the median, where would you expect the mean of the distribution to lie? Now, why? First of all, the median is going to be where 50% of the area is to the left and 50% is to the right. So relative to the median, given that this is a skewed left distribution, relative to the median, I'm going to find my mean towards the tail, to the left, which is 2.828, which is really close to Q1. Q1 was 2, remember? Now, the mean is less than the median because the curve is skewed to the left. What proportion of the observations lie below x equals 1? So what proportion is this little piece worth? Well, if x is 1, what is y? Y is 1/8. Remember, y is your height and your triangle. We're just cutting these up into smaller and smaller triangles, remember? Okay, so now, returning to my area, I'm going to put my height in as 1/8. And I'm going to find that 6.25% of the area is to the left of 1. What proportion of the observations lie above 4? Okay, here's 4. What's the area to the left of 4? Area to the left of 4 is 1. So is there? No, there's nothing above 4. So no proportion of the observations are there. Let's look at a uniform distribution. So again, not a curve, but uniform means straight line across, right? So now our range is from 0 to 5. So I've got a rectangle here that I'm talking about, from 0 to 5 on my x-axis, and some height so that the area of my rectangle equals 1. Here we go. If I have a height of 0.2, then and a width of 5, then that was going to give me an area of 1. This is my density curve, if you will. Find the proportion of temperatures that are greater than 1 degree Celsius. So greater than 1 degree. So I see I can cut this up into equal rectangles here. 1, 2, 3, 4, 5 rectangles I can slice at each single degree point. So one of those 5 rectangles is missing from the degrees, the area that is greater than 1. So I have 4 out of the 5 rectangles, 4/5, or 80%. Or I can take 1, 2, 3, 4 degrees and multiply it by the height of 0.2. Find the proportion of temperatures that are between 2 and 4. Between 2 and 4. Well, I have 1, 2 degrees multiplied by 0.2 height, and that's a 40%. Find the median, Q1 and Q3. Median, remember, is where 50% of your temperatures are going to the left and 50% to the right. Being that this is a uniform distribution, it's going to be right at the dead center, 2.5. Q1, well, that's going to be halfway between the median and the minimum at 1.25. And let me see, 3.75, sure enough, is where Q3 is. Okay, so now we've played around with the concept of some density curves, and I will see you in class tomorrow.